Hi guys, I thought we would go ahead and practice algebraically finding domain of functions, so we're going to do 6 problems. Alright, in this first one, we look at it, we recognize that it is a logarithmic function, and so then we're going to go ahead and try to solve and find the domain of a logarithmic function. So go ahead and try that. Okay, now that we have selected an answer, let's go ahead and double check it. So for logarithmic equations, what you have to do is you have to take whatever's inside of your parentheses and you have to make it greater than or equal, or excuse me, just greater than 0. And so I set that up. I'm going to subtract 2/5 from both sides. And I get negative 4/5 x is greater than negative 2/5. And then you can either divide by negative 4/5 on both sides, or I really like to multiply by the reciprocal. So I like to multiply by negative 5/4 instead. Okay, and when I do that, I end up with x greater than negative times negative is positive. The 5's cancel, so I have 2 over 4, which is also 1/2. So then we can go ahead over here and write our final domain for this equation. X, the set of all x values such that x is greater than 1/2. That would be the domain for this equation. All right, let's go ahead and try it with another logarithm. Okay, so then we do the same thing. This is a common log, so it doesn't say ln, it actually says log. It has a base of 3, and that's fine. We still take whatever is inside of our parentheses, and we make it greater than 0. This one's a little bit easier, because all I had to do was add 1 to both sides. So my domain for this equation will be all x values such that x is greater than 1. All right, let's move on to radicals. So for radical equations, remember what you have to do is you have to take whatever's underneath your radical and make it greater than or equal to 0. So go ahead and get started on that one. Okay, and so then now I take whatever is underneath my radical. I make it greater than or equal to 0. This is a quadratic, so I'm going to have to factor it. So just off to the side over here, I'm going to do that. So I have to figure out what multiplies to 32 and adds to negative 12. Let's see, that would be, I think an 8 and a 4 give me 32. I need a negative 12, so I need them to both be negative, negative 8 and negative 4. So then this factors into x minus 8, x minus 4. Then I have to solve them individually to figure out what my solutions are. X equals 8 and x equals 4. And remember, for my quadratics, you want all of the numbers less than or equal, or excuse me, well, for quadratics, but underneath your radical specifically, you want all the numbers that are less than or equal to your lowest solution or greater than or equal to your highest solution. So when I write my domain, nicely, we want the set of all x values such that x is either greater than or equal to 8 or x is less than or equal to 4. Beautiful. All right, go ahead and try this one. All right, and so I take what is underneath my radical and I make it greater than or equal to 0. Again, this is one I have to factor, so I have to figure out what multiplies to negative 56. Uh-oh, got a lawnmower in the background. We'll be all right. And then adds to negative 1, so that would be a negative 8 and a positive 7, I believe. And so then this factors into x minus 8, x plus 7. Then I have to solve them individually. So I get x equals 8 as one of my solutions and x equals negative 7. And then for radicals, you want whatever is less than or equal to your lowest solution and then greater than or equal to your highest solution. So for my domain, I got x such that x is greater than or equal to 8 or, let's make that a legible or x is less than or equal to negative 7. All right, let's go ahead and try our last versions of this. So for this last last type of problems, we have rational functions, and you can tell because they have a fraction that's occurring, right? So I have a numerator and a denominator. And for rational functions, you just have to make whatever is in the denominator. We're going to make it equal to 0. Oops, I already almost gave it away. Go ahead and try it. All right, now I'm going to finish it. So we have to make whatever's in the denominator equal to 0, and then you're going to not allow that to be in the domain. Now, careful here. This is a quadratic, so we're just kind of a flashback to quadratics. We will review them in more detail later, but this is still an x squared, and it's still got an a, and it's still got a c. Our b value secretly in here would be 0, right? Because normally we have x squared, ax squared plus bx plus c, but we have no regular x's here, which just means that our b value is 0. So when I multiply to AC, I'm basically figuring out what multiplies to -4 and then adds to 0. And so that would be a 2 and a -2. So this factors into x plus 2 and x minus 2. And so then when I separately solve these are what would make my denominator equal 0, and because we don't allow that in mathematics, as dividing by 0, makes the universe explode, so to say. These are what would make that 0, and so we don't allow them to be in the domain. So we would say the domain of this rational function is the set of all x values such that x is not allowed to be -2 or +2. All right, go ahead with this last one. All right, and so then I take what's in my denominator automatically, and I figure out what makes it equal to 0. Got another quadratic here, so let's see. We got to figure out what multiplies to 7 and adds to 8. Well, that's hopefully pretty easy. 7 and 1, because those are the only things that multiply to 7. They do, in fact, add to 8. X plus, oops, not 8. X plus 7 and x plus 1. And so then if I make it proper x, separately solve those, you get x equals -7 and x equals -1. And so those would be what would make my denominator equal 0, so we don't allow them to be in the domain. There you go. All right, go ahead and complete some more practice, or let me know if you have any questions.